Hello and welcome to the Being an Engineer podcast. Today we're talking with another Aaron Eden, an AI process automation leader at Intuit and longtime innovation catalyst. Across roles spanning enterprise, startups, and community building, Aaron has helped teams turn messy manual workflows into scalable, customer-centric systems using robotic process automation, RPA, AI, and lean experimentation. He's coached executives, launched programs that accelerate time to value, and co-leads Tucson's AI Trailblazers community, where he brings people together to put AI to work in the real world. Outside of all these things he's doing with AI and at Intuit, Aaron was also a keynote speaker at the recent PDX in-person event in October last month. So I got to meet Aaron in person there, and he delivered an incredible talk. And I asked him if he would consider being on the podcast so we can share this content with even more people. So if you weren't at PDX, we were sad to miss you. And you still get to hear some of the content that was shared at the event. So Aaron, thank you so much for being with us today.
I'm excited to be here. Thank you.
So AI is like all the rage these days, obviously. It's popping up everywhere. How did you first get into AI and automation?
I've actually, I'm a geek through and through. So I started programming when I was probably about 12. And I remember I actually ran a bulletin board system for a little while. And there was these scientific papers that would actually get passed around in these bulletin board systems. And I came across one that was on neural networks. And, this was probably, I would guess this was like the mid 80s or something like that. And so it was very early days with regard to all of these things. It totally intrigued me, but all of the math was totally over my head. I could hardly understand it. It was intriguing. And so from that point forward, every time something around that has popped up, I've sort of latched onto it and found interest in it. Still to this day, the math is totally over my head. When I had my last consulting company, it was an innovation consultancy. And one of the biggest problems that we had was I'd go to a conference and I'd meet somebody from General Electric. I'd meet somebody else from GE Aviation, someone else from General Electric, something or other. And all those would be in my CRM system, and it's the same company. And as a change management sort of approach, we want to know who are the hearts and minds that we're touching inside organizations. So one of my first sort of touches into this technology space was building a small NLP system to see that those are actually the same company, or there's a high likelihood that those are the same company, and being able to sort of deduplicate our CRM system. And then more recently, when all of the large language models really started taking hold and those kinds of things, I got totally sucked in. It was, watching videos on YouTube nonstop, reading articles, reading scientific papers, this kind of stuff. And it was this kind of, for me personally, it was this magical moment where all of these things, the technology, geekery, software development stuff that I had in my background, I did a lot of data warehousing and business intelligence work. And then the sort of most recent parts of my career have been very much focused on the people side of things and change management. And kind of all of this came together for me personally, where I'm this is the way that all of these things that I've learned over the years kind of come together. And what I'm seeing from all of this is the technology part of it is actually not all that difficult. It's the people side of it that's really difficult. And so those skills in innovation and lean startup and design thinking and those kinds of things have come in very useful for being able to help people navigate this kind of crazy change.
I'm curious. It was, I don't know, 3-4 years ago when I really started being aware of basically ChatGPT. I think to say AI would be overstating it, but ChatGPT was on my radar 3-4 years ago. I started using it. very quickly understood the power behind it, especially for mostly what I do these days is like marketing and business development and sales around engineering. And
Hmm.
I have used it a lot in those spaces. Um, but that was me, and I wasn't really looking for AI or following the that part of the industry up until then.
Hmm.
You clearly were watching all the YouTube videos and just soaking everything up
Yeah.
before LLMs became or started to become mainstream. What what was it like? Where did you see that as like an imminent future, or was that community just kind of unsure what it was going to be, if anything, when it was going to be? How much
Yeah.
uncertainty was there, or was there a pretty clear trajectory, and that you and that community were all kind of just waiting until the time came?
I don't know that it was a clear trajectory. I think what happens, I mean, the fact of the matter is, like, as humans, we've been working on this technology for 100 years, right? It's not new. What's new is some specific breakthroughs that have allowed us to do it at a significantly greater scale than we could before, right? The In this case specifically, the transformer architecture was sort of the breakthrough that led us to these large language models and the ability to do them at super high scale. Um, but like NLP and those kinds of things have been happening for a very long time. Just was not nearly at that scale or level of impact.
What does
So there's
NLP stand for?
Oh, sorry, yes, neuro linguistic programming,
Oh, okay. So
or
I've
natural language processing, depending on whether you're a doctor or an AI geek.
the neuro-linguistic programming, I've heard the term, but I've heard it in the context of like, I don't know, like Tony Robbins seminars,
Yeah, yeah,
which
yeah.
it seems different than what you're talking about.
Yeah. Sorry, I made a joke there, but it wasn't a very
Oh,
good joke.
got it. I'm just
Neurolinguist,
dumb.
it's overloaded. No, it's overloaded. It has two meanings: neurolinguistic programming and natural
Okay.
language processing. So sorry. Yeah. So natural language processing, has been around for quite a while, and like that's what I was fiddling around with when I was sharing that story about deduplicating business titles.
Got it.
So no, there's been a lot of people working on this for a very long time. I think there's a lot of what's referred to as like emergent properties, new capabilities that these things are able to, like, as we increase the scale, like, oh wow, it can do that thing that I didn't realize that it would be able to do. So as the scale increases, a lot of those are surprises to everybody. It's like, scale it up and see what it can do this time around, right?
Mm,
It continues to get smarter. So
hmm.
anyway, so short answer to your question is really that, like, it's been around for a while, not new. Lots of There's surprises in what it's capable of, but not. Um, I don't think anybody knows what the trajectory is of where it's actually going.
Interesting. Okay. All right. So let's talk a little bit about how engineers can
Yep.
use AI. What are a couple of ways that engineers can at least dip their toes into the AI pond?
Yeah. Oh man, there's so many opportunities. You know, the immediate one that I'm sure everybody thinks about right off the bat is using it for engineering. So whether that's writing code, or helping with designs of things that you're implementing, helping explore possibilities. Because the way I like to describe it is, like, you basically have, like, um, you have the Einstein of, like, every type of job on the planet in your pocket with these tools. And so, like, for me as an example, I'm pretty decent with, like, back end kind of software development, primarily around databases and data architecture and this kind of stuff. Like, that's an area of strength for me. I suck at front end kind of stuff. In fact, like, one of my good friends leads the React team for Meta. It's constantly trying to get me to, like, do React, and it's been my nemesis for years. um, but, like, last year I built my first React application, and actually I can't take credit. V0 wrote my first React application, and I've learned through that, and now I've built a few applications with it. I'm still terrible at it, but in that example, I don't need to depend on somebody else for that, at least to get it started. You still want somebody with some expertise in those areas, but, like, now as an engineer, there's actually this broader range of things that I can take on that maybe I couldn't have taken on before. Um, I can at least get it up and going. And like thinking about thinking about HR teams on most large organizations, they usually will talk about employees as like, we're looking for a T-shaped employee. So T would be like on the top part of the T, that this employee is able to go broad on a bunch of different topics. And then the base of the T is they can go deep into into like a single area of subject matter expertise. But what these AI tools actually enable each of us to be is sort of a unicorn employee, where like I can go broad on a whole bunch of stuff and I can actually go fairly deep on those things with the support of the AI. I do have to still have some expertise. Like you can't vibe code your way into a production application without really knowing what you're doing, at least not at this point in time. Maybe in a week or two that'll be possible, but like today that's not possible. You still have to have depth of expertise. But as these tools continue to get stronger, like we as engineers, I think are just going to have to continue to sort of take on more. My role inside of Intuit is on a process automation team. We've actually been experimenting with me playing both sides. So I'm both a business systems analyst. I'm going and gathering the requirements, engaging with the business users, understanding their current processes, documenting what we're going to go and automate, and I'm implementing it and delivering the automations, writing the code for it, putting it on our production systems, et cetera. And so, I think a lot of organizations are sort of experimenting with like, what are the boundaries of what a single engineer can do and should do, and what are the we don't know where it's going. And so I think back to kind of where we started the conversation, it's important as engineers to lean into our curiosity and to go and explore new things, because they're changing so fast. And anybody that says that they know where it's going, I think is BSing you. We can't predict the future. There's some scenarios like, yes, more stuff is going to get automated and we're going to have to do more work. That's sort of a given. How much? I don't know. Is it so much that we need universal basic income and that we don't have to have jobs? Or is it, enough to where we just have, a broader suite of things that we're taking on? Don't know.
Yeah, we had a similar experience here. You talked about like the going broad and deep on different things. We don't do a lot of software, at least not a lot of embedded software. We write PLC code all the time for our automated machines, but not a lot of like C# or that type of embedded software. And we had a project recently where we needed to do some of that. And historically, we probably would have just subbed that out to an electrical engineer or someone else. But this time, one of the engineers who knows a little bit of software himself just opened up ChatGPT and said, "This is what I need to do." And there was the code, and he put it on. I think it was just an Arduino or something, but it worked great. It was perfect, and it was super fast. It was like maybe a couple of hours of work versus, we probably would have paid a few $1,000s in the past to have that done. So this leads me to my next question. What are some of the specific tools that engineers should know about? You mentioned V0. You also mentioned vibe coding, which is not a tools per se, but more like a genre. Maybe can you talk about that a little bit?
Yeah. Thank you for calling those out too, by the way. Please do, anytime I'm using acronyms or strange terminology, or maybe not even strange, just that it needs to be defined. So yeah, thank you. So vibe coding is kind of like it's a slang way to reference writing computer code using AI tools or using AI assistants, in a case where maybe, like in the example you just gave of one of your engineers that maybe doesn't have that experience themselves, they got a good vibe that the code that it came up with worked and it was functional and you got it to go. They don't necessarily have the deep expertise to dig into that to know whether there's potential, minor bugs or issues hiding in there, right?
Right. Yeah.
But I'm not trying to talk badly about them. I don't know them, but using me as an example, right? When I built that React app, there's probably some garbage code in that React app that I built that someone that knows what they're doing would look at and go like, no, that's bad practice, right? So like that's really the reference to vibe coding. It's like being able to write code in an area where maybe you don't have depth of expertise, and so you have to kind of go on vibe. And sort of a spectrum of people that are like, on one hand, like I've never written any code in my entire life and I'm going to use this thing and I'm going to build an application and I can successfully build an application. And that would be sort of a completely vibe coded. So I'm realizing that I forgotten your question, Aaron. I'm sorry.
That was half of my question right there. The
Yeah,
other
yeah.
half
The
was
other half.
what are a couple of specific AI
Ah,
tools?
yes. Yeah. So specific AI tools. Oh man. Okay. So I'll list off a few in software engineering, but I know also from my research, before speaking at the conference at PDX a little while back, I found a handful of other ones as well that normally I wouldn't touch on as a software engineer, but definitely exist and are important from an engineering perspective. So on the software engineering side of things, like today, Claude Code and Claude Code, Cursor. I don't know. There's a bunch of AI coding, either command line interfaces or tools that can plug right into your development environment that will basically help you write code in your favorite language. Personally, I'm a total Claude Code addict. I love it. I think it's really well done, and I've got a bunch of pre-built prompts and other things that help me sort of make sure that it's done at a certain level of quality and those kinds of things. So Claude Code, this last week, I've been experimenting with Google's brand new anti-gravity tool, which was, they acqui-hired the Windsurf team, which was kind of a competitor to Cursor. And that was their first release under the Google brand. But it leverages the new Google Gemini 3.0 model, which is really, really good. So I'm enjoying that so far. That's been interesting because, like, as a developer engaging on using Claude, it's a lot more sort of interaction of like, hey, Aaron, I'm about to do this thing. Like, you okay if I do that? Or, whatever, maybe we should do this thing, this other. Whereas anti-gravity is kind of the opposite approach, which is like, I give it something that I want it to go do. It goes and does the entire thing and then comes back and kind of gives me a write-up on what it did, right? So, and then it'll do some code review along the way, but like, it's kind of completely different approaches. So I've been learning AWS, which is not something I had a lot of experience with. And like Claude Code has taught me not all of, but much of the AWS infrastructure that I've needed for some of the projects I've been working on, over the last year or so, because of that approach of sort of like explaining and teaching you along the way. Whereas like, I think if I had anti-gravity at that point in time, I probably wouldn't have learned as many of those things because it would have just taken it and done it. So not right or wrong, just depends on what you need. So definitely those like those IDE tools that can put code right in there. They can actually review the entire code base rather than the sort of like go into ChatGPT, ask it to write something, copy it over, go back and forth. You can absolutely code that way. It's just a lot slower. And, for probably $20 a month, you can have one of these other tools and it's way faster. Some of the things that I found really interesting in preparation for the PDX conference, which I have very little experience with, but I'm going to mention them anyway because I know they're beneficial to your audience. One of the things that I came across was there were two really cool NVIDIA tools. There was one tool that was a simulation platform where if I've designed something physical and I want to simulate wind drag, or I want to simulate how it would handle specific types of liquids, or I want to simulate how it would handle certain heat level, whatever, like all these kinds of simulations. Effectively, like the way I think about it as a software developer, like that's all your unit tests. Like it would basically do all of your tests, like a bunch of simulated testing to make sure this design you came up with was going to be really solid. And they've built this entire sort of omniverse simulation platform for being able to sort of simulate any kind of physics situation that you might have, to give you kind of an early read on that. So some of those NVIDIA tools were really super fascinating.
And that
The
could be really
Mhm.
disruptive. Like the incumbent right now in that area, the simulation area, is probably ANSYS, and it's like $10,000-$20,000 software
Mm.
plus all the training that is needed to really set up and understand the results of these simulations. So if an AI tool can make that process much simpler, man,
Mhm.
that could be really disruptive in the industry.
Yeah, there's a lot happening in that space too. The other interesting part of it is that like on the robotics path, the same kind of thing of simulations where you can put 1,000 virtual robots into the same simulation at the same time, and then have them using reinforcement learning, having them learn what is the way to be able to navigate this environment, and that environment mimics the real world. So now rather than having to build a physical robot and run that over and over in the real world, you can now get millions
Mm.
of simulations. There was a really interesting experiment that was done with one of the like robotic dogs, the like spot dogs, right, the quadruped kind of deal, and they put the dog in a simulation where it was on top of one of those like bouncy exercise balls, um, and they told it need to stay balanced on the exercise ball. Um, Through these millions of simulations, it learned to balance itself on the exercise ball, and this video that I saw was literally the quadruped like like up on one of
Wow,
those balance like staying. It's like kind of scary actually
that's
what was possible,
amazing.
but
Almost
um,
human, right?
yeah, totally. But given enough, like it was able to have millions of experiences to now be able to have that
Yeah.
level of balance, right? So anyway, so these like simulations and virtual environments and digital twins and like all those kinds of things are really powerful. And then the second one that I found, I think was one of the Adobe tools that was that was to assist with the actual design of a specific component. And what I found was really interesting about that was um, all of these generative tools of like, go into Gemini and ask it to generate an image for you, or go into Suno and ask it to generate a song for you. You write the prompt, and based on the quality of that prompt, you get a generative result from what it's created, a song or a poem or an image or a whatever, right? And you learn very quickly, like, oh, I left that detail out of the prompt. Like, that's why I got that weird thing, right? But this generative design tool actually sort of took the opposite approach, which is that what you do is you go into the design tool and you basically map out boundaries for what it's not allowed to touch.
Mm.
Um, and so in this case, the like simple example was like a wheel on some piece of furniture or something. They were trying to redesign this wheel. So they went in and they basically blocked out all of the constraints, all the things that the AI is not allowed to touch. You can mess with anything inside of here, but like these things you do not touch. Um, and then they allow the generative tool to basically come up with a whole bunch of different possibilities of what might be a really great design for this specific set of constraints. And then it would give back the list of all of the possibilities with sort of a prioritized list, so the human can now choose like which ones do I want to experiment with. And now thinking about the simulations I was talking about a minute ago, now you could take that thing, put that design into a simulation, and see whether it's going to meet your requirements. So your ability to iterate should increase very significantly, because you can say, here are the top 6 designs that I, as the engineer for this thing, believe are most likely to be successful based on everything that I know. And now I can go put those into 6 simultaneous simulations and come back with some data that says like, okay, yeah, your gut was right. That one on top was probably the best performing. Let's go ahead and actually, 3D print a prototype or whatever.
Yeah.
Kind of move on to the next step.
Yeah. Short break here. I just want to share with everyone that hopefully you have the time to listen to the full episodes of Being an Engineer podcast. However, we understand that life is busy. And if you want just a concise summary of the episodes, go ahead and sign up for our newsletter. Go to thewave.engineer, and you'll see on the side, on the right side, there's a little banner. Sign up for the PML Pipeline Media Lab newsletter. So there's other information that we put in there as well. For example, details about, the upcoming PDX or PDX webinars, or articles that get released on the Wave, and then of course a summary of each week's podcast. So if you want just a concise breakdown summary of all the things that we're doing on the media side here at Pipeline, sign up for the newsletter, and you will get I think it's bi-weekly, every other week you'll get an email with that summary. Okay, back to our conversation here with Aaron Eden. Let's go back to the using AI to write software code just for a minute. You mentioned that there are some prompts that you have created that help you ensure you're getting quality code, or maybe there's some guardrails. Are there any best practices for prompt engineering that you can share with the audience?
Yeah. The short version of the whole thing is that it's consistent with what you'd be taught around like the software development lifecycle and the things that you should do as a good engineer, right? Which is that I should start by figuring out what my spec is, what is the high level architecture of this thing that I'm going to build, and actually put together a detailed plan for what I'm going to build before I start building. Then, in many camps, it's sort of a test-driven development, right? Write a test, then run that test. It's going to fail because you don't have the code written yet. You write the code. The test should now pass. You're going to kind of repeat that test-driven process. All of that works really well with the AI. It doesn't, in most cases, it doesn't naturally follow that. And so the prompts really are around getting it to sort of follow that. So as an example, I have one prompt that I can execute in Claude Code that is my planning prompt, where I tell it, like, I've got a whole set of like, okay, great, you're going to ask the user questions to clarify the requirements for this. Then you're going to propose what the plan might look like to implement this thing, and you're going to go back and forth with the user until they agree on the plan. Then you're going to write the plan into a plans folder in a markdown file, where now I can go back and I can edit the plan and go like, yeah, that part's not quite right, whatever, right? So like that's one prompt, which has come up with a plan. Then I've got a second one that is something around the effect of like, you are a world-class software architect. I want you to review this plan for scalability, for security, for these other things, and I want you to critique the plan, right? So then now a second one comes through and starts critiquing the plan. Then I've got a handful of other ones kind of depending on the situation or the type of thing that I'm trying to build. But like there's a lot around coming up with a really solid plan and making sure that is well done. In that example, using the sort of cutting edge models, the Gemini 3 Pro or the Claude 4.5 Sonnet or the Claude 4.5 Opus, those like really big expensive models, they work really well for those planning steps, and having them go and do internet research on the libraries to use or the best approach or gotchas that come up from people trying to use these same systems, like capturing some of those things up front. Once you've got a really solid plan, in a lot of cases, you can actually use one of the less expensive models to execute the plan. They'll follow the steps really well, but they won't have the size and the scale or the creativity kind of stuff to kind of look at the bigger picture, right? So those prompts are all around like the planning. Then I've got another set of prompts around the execution, another set of prompts around, running the linting, running the like bandit security tests, making sure unit tests pass, like all these other kinds of things around sort of checking the quality of the code. So it's really like, and the way that I've gotten to that point is like, you ask it to do something and you see it makes a mistake and you go like, okay, let's change that prompt to not, so that we've got a command in there. So it's like, okay, we need to do this other thing, or maybe I've got a whole other prompt of like, all right, let's check the security, make sure that kind of thing doesn't slip through. But you're kind of just building it up over time. So I would say like, if you're just getting started with this stuff, don't worry about all that. Like take a first stab at it and say like, okay, great, let's go grab a planning prompt that already exists out on the internet. There's lots of people that are like posting these up on GitHub and other places. You can find them for free, not a big deal. But like go grab somebody else's prompts for an SDLC, software development lifecycle. Um, find somebody else's as a starting point and go play around with them, or try without any prompts and see where the AI screws up and start writing your prompts around that. Lots of ways to eat at that.
I've even noticed that I can tell. I mostly just use ChatGPT. I haven't really explored other LLMs yet. But in ChatGPT, I can tell it to help me write a prompt for whatever this thing is.
Yep,
And it 100% of the time gives me a prompt that is way more detailed than what I would have written if I just, spent a
exactly.
couple of minutes writing it myself. So it, it can even help you write the prompt is my
Yep.
point, which has been really useful. Going back to specific tools, there was another one that you brought up at PDX that we've actually
Mhm.
started exploring and are doing some testing with and is super promising. It's called Lydia. Lydia, I think. Lydia.ai.
Lindy.
Is that right? Lindy.
Lindy.
Ah, thank you.
It's okay. Yeah,
Lindy.ai.
no worries.
Yeah. Can you talk a little bit about that one?
Absolutely. Yeah, Lindy's one of my favorites. Shout out to Flo over at Lindy if you see this. So he's a he's a buddy of mine who lives out in San Francisco. And ex early he was at Uber in some of the early stages of starting Uber. Anyway, yeah. So Lindy is a no code automation AI based automation tool. Um, so the way that I'm not sure if they're describing it this way anymore, but the way they described it at the beginning of Lindy was if ChatGPT and Zapier had a baby, this is what would have come out. So
That's such a good way to
um,
describe it.
so the what makes it really magical, so it's a workflow designer tool. You put a box here that says do this thing, you put this other box in another spot, do this thing, put another condition over here, etc. Connect the dots together and now you've got a workflow. What makes it really magical, if you think about like Zapier or these other tools, any of these designer tools that you probably have engaged with over the years, you get like a design panel in the middle, and on the right hand side you get a configuration panel that's like configure each of the boxes and tell it what the variables, what the settings are, et cetera, et cetera. Um, what makes Lindy really magical is that all of those boxes on the right hand side have an automatic property where you can say, just let the AI choose what to put in this box. Or I can say, let's have the AI choose, but I'm going to give it a prompt for just this box to sort of guide it for how to handle this, filling in this box. Or if you want to pick it manually, you can pick it manually too. So behind the scenes, it's basically a big AI agent. It's all being run by the large language model. Says like, oh, I pulled this data in from Google Drive. I've got this Google Doc that I want to like, I don't know, what's a good example? I want to more efficiently keep my project status updates current in Jira, and so every time I have a meeting, I'm gonna like fire off an email to a special email box that's got some of my notes in it, and it's gonna get attached to my project. So whenever my boss asks me for a project update, I can just pull it right out of there. So in that example, I have Gmail connected in as a trigger into Lindy that's like checking my Gmails. The AI can read the content of that email to say like, oh, that's a project status update. It can tell based on, reading the words. And then it can go and, put that data into Jira or whatever the case may be. And you don't, it's all an AI agent that you can basically spin up in, minutes. So very powerful platform. The last thing I'll say about it is that like what you usually end up with those kinds of tools is like, it connects into this system that I need, but not this other system that I need. But they've got like 6,000 connections or something like this. So it's pretty well covered as far as those things go.
Pretty well connected app.
Yeah.
I the use case that we're experimenting with right now is more of like a sales based use case.
Mhm.
But we have a product called Easy Motion. It's a simple way for engineering teams to automate things, motion based and sensors and things like that. And we're looking for customers for this product, right? And so we're building this Lindy workflow where we can tell it, okay, we've got this product, Easy Motion. Here's what it does, and and then it'll go off and start looking for companies out there that might have need for this product, that might find it beneficial
Hmm.
to them, right? And we'll give it some context, right? So it understands what kind of a business, what kind of a company would actually use Easy Motion. So it'll go off, it'll find the companies, it'll
Hmm.
identify some of the engineering leaders there, and it'll go find their contact info, and then it'll actually like create an email and send it out. And of course, we have like some checks in there because we don't want it to go off the rails and start doing weird things. But
Hmm.
pretty amazing that like a tool can do all that without having
Yeah.
to code anything yourself. And then as you were talking, I thought of another potential use case for this. We build automated machines and we always deliver a user manual with them. And the user manuals, they're just a pain in the butt to write. Like nobody likes doing that
Yeah.
documentation. They take a long time, they're tedious. And I wonder if there's a workflow that we could create where we kind of feed that workflow, that AI information about the machine, like during the course of development. And so by the end
Hmm.
of development, it kind of it knows pretty well what this thing does and how it works. And this then we could just push a button and say, okay, create the user manual for this machine. And it's probably not going to be perfect, but maybe it gets us, 70, 80% of the way there.
Absolutely. No, I think that's a great use case, and in that example, I would also like putting my lean startup hat on for a moment. Like I would also question whether there's anybody actually reading that manual, and so like I would look at like is there a different form to deliver that knowledge to
Mm,
the person in, right? Could you could you have a, I don't know that chat is the right interface, but could you have a chat bot that your end users are actually chatting with the code, or they're actually chatting with the design
mm.
specs, or they're chatting with the artifacts that you need to create as an engineer, not the other stuff. And can you get them a bunch of their questions answered from something like that? Like, is that intermediate document even necessary? Maybe it is,
That's a
but
really
I
interesting
would challenge that.
idea. Yeah, just deliver a AI chatbot that a user can actually ask questions to.
Hmm.
That's a really neat idea. Okay. Yeah. Um, let's talk about trust and AI. AI
Hmm.
obviously super powerful. It's
Yep.
increasing our productivity all over the place, but sometimes it gets things wrong. How should we be thinking about our trust of what the AI, these LLMs, tell us?
Yeah. Oh, you shouldn't trust anything they tell you. Um,
Okay.
like, like seriously, like, thinking about code that I'm having Claude Code write. I have to check all of it. I need to go through. I need to review the code. I need to make sure that it didn't put some weird. A great example. I had a simple automation that I was working on earlier today, that that basically allows my team at Intuit to interact with this chatbot and basically do all of their like Jira stuff. So like they can go like, oh, move that story into in progress, or hey, I'm done with that, or add a note to it, or whatever. Right? Don't need to go play in Jira all the time. Can just like ask the chatbot to go do it for you. Um, uh, was making a modification to that AI agent and its connection to Jira. I was running into an issue where there was one field that it was messing up. I couldn't update that field for some reason, so I'm trying to fix a bug. Right. Um, in the process of doing that, um, it ran into the AI tool. Ran into an authentication issue. My personal token for Jira wasn't working as it should have, and so to troubleshoot it, it thought maybe the token was not being sent to Jira properly. So it added some workaround code to get into that. Well, once I caught that, I didn't see when it added the workaround code, and once I caught what was happening, I'm like, oh, my key expired. I just need to give it a new key, and it'll be okay. So we got through the whole thing, got the bug fixed, etc. Um, I checked the code in, and one of the other developers that was reviewing my PR were like, "Hey, why do you have this sort of double authentication thing? Like you're passing the authentication token twice. Is that necessary? Like which one is it actually using?" I went back and looked. I'm like, "Oh, like actually, it just made that was a workaround. It was testing to try to figure it out, right?" And so like even in that example where something small, if you're not checking it, you're not like in that case the right thing happened, which is code review caught it. I should have got it, but it also got caught in code review. And so like you can't trust it. It makes mistakes all over the place. It'll come up with things that aren't possible. And so like in software development, like the tests are your friends. Having the tests in place, because then when it goes and changes something weird and one of your tests breaks, you know what happened there. But you have to do code reviews of it the whole time. Same thing if you're having it write documents for you, or you're having it automatically go and find prospects on the internet to go after, or you're having it write emails on your behalf. Like, it is really important to make sure that you're designing these processes with a human in the loop, and that you're verifying things as they come through. It can get you 70 to 80% of the way, but don't trust that it's getting you 100%. Just assume that it's not. It's best to do that. Maybe next year or the year after, maybe those things won't be necessary, but at this point in time, you have to really just assume that it's like a super smart, like right out of school kind of intern. like it knows everything, but it just doesn't have a lot of like the school of hard knocks, you know?
And to be fair, humans aren't right all the time either, right? Like
No,
humans
definitely
make
not.
mistakes. Humans provide false information. So it's not like ChatGPT or AI, these LLMs have some monopoly on being wrong on
True.
occasion.
Well
Um,
said.
to what extent do you think that LLMs will get to the point where they, I, I don't know, the definition of wrong even could come into play in this answer, but they'll get
Mm.
to the point where they're right at least as often as humans. Like they're as or more trustworthy than a human
Yeah.
source.
I th- so if you look at the benchmarks, so there's each time a large language model is released, there's a whole slew of benchmarks that they're basically run against, right? As an example, there's one called SWE-bench, Software Engineer Bench benchmark. It's got a whole bunch of like different software engineering challenges, and you basically throw a challenge at the model and you see, can it solve this? Can you solve it correctly, right? They've got ones around math and engineering, and like there's just benchmarks galore. Um, in one of my workshops recently, I posted this chart that basically shows how all of these large language models are progressing against all of these different benchmarks, and they're all going up into the right, which is
No, nice.
at like the 80 to 90% level is sort of above human average around these things, and like very quickly they're going up and above that level. So there's that part of the equation, which is like they're all getting better, and so it's likely that some point in time soon that's the case. Um, but but it's sort of this like it's like this jagged kind of a thing where it's like it's super knowledgeable in an area, but then it'll make a little mistake right next to it, right? And so it's not even. It's not like it's it's amazing in all of science. No, it's really good in this one area, but there's other little weird things over here where it's terrible at them. And like there's just so many different possibilities. There's no way for us to know where those edges really are. So I don't know. I think they're absolutely going to continue to get better. The other thing that's happening that I think a lot of people sort of get hung up on the benchmarks and that kind of stuff is that like what's also happening is all of the tooling that we're building around them is making them significantly more capable. So as an example, using GPT 5.1, like the model itself, not necessarily the ChatGPT user interface, but like using that model compared to like Google Gemini 3 Pro, just the model, the capability of the models is significantly increased when you wrap Cursor or Claude Code or these other things around it. So when you create kind of this harness around it, it says like, no, here for this task, here's how you're going to be successful with this task. It becomes significantly better, to the point where like on their own, generally the models are terrible at math, but they can write Python code like crazy, and they can solve almost any mathematical problem with Python code. And so you give them that tool, and like off to the races, right?
Okay.
Um, so like, yeah, I think there's natural limitations in where you can go with the large language models, but I don't know that we know where those boundaries are, and we also don't know how far the tooling around them can take us. And so, like, in a lot of ways, it's better than many humans. Like, it may not be better than me as a software developer, but it's better than me in a whole bunch of other areas. um, like, so, like, definitely, don't get wrapped around the axle around like where it's going, or will it be artificial general intelligence, or will it, is it better than humans? I think the key takeaway is it's better than us in a lot of different ways today. And so, like, learn how to use it, learn how to be more productive than your colleagues, and 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 we'll see where it takes us.
Do you know, is the rate of improvement of these AIs increasing, or is it kind of what's the stagnant gives the wrong connotation,
Yeah,
but
kind of
consistent, I
plateaued or
guess.
whatever.
Yeah,
Yeah,
yeah, or is it starting to plateau?
yeah. I've seen debates in both directions. I think it's like, it's interesting because, like, everybody was debating this whole, like, oh, like the models aren't getting significantly better like last year, and then Gemini came out a couple of weeks ago and is now like off the charts compared to a bunch of the other ones
Mm.
have been able to do. Um, but I, I I don't know. I don't know how much of that is their internal infrastructure and internal magic of stuff they've wrapped around the model versus like what the model itself is capable of. Um, but the other really interesting thing that's happening though is like, um, in that debate, um, there the debate is primarily about large language models, that specific like transformers with, specifically around language and what we're able to do with those things. But we have generative models around music, and generative models around graphics, generative model around 3D worlds, generative model around 3D design, all these different models that are completely different forms. And what a lot of organizations like Google and these others have figured out, like, if you go into the Gemini web app and you interact with it, it's using its image generation model, it's using its code generation model, it's using. So we're starting to create these like models that are very surgically focused on specific topics or specific capabilities, and then using the large language model as kind of a router to say like, ooh, they need a picture, I'm going to send that to the picture model, I don't need to do that, right? um, and so, um, I don't know, man. Like, I think the combination of the stuff wrapping around it plus the specialized models, um, like, I think we're going to be seeing some pretty significant acceleration for the short, the for next few years, um, and who knows whether Terminator is born or not. But,
Skynet is coming. Yeah.
yeah, I,
Um, Along those same lines, what do you have any guesses or expectations for what will happen in the next like 12 to 18 months around AI? What should we be anticipating?
um, I think you should. I think you should, at a minimum, expect that the same patterns that have already been established continue, which is that the models continue to get better, the models continue to get faster, the models continue to get cheaper. Like, those things continue to happen, and there's so many companies going after it, and so many scientists that are doing exploration and research in the space that, like, those things are likely to continue to happen. Um, and so, like, I think the key is, like, we need to be constantly learning, we need to be, uh, open-minded and exploring new things, and we need to be focused on, like, helping each other through this, because it's not, it's not easy. It's like, as a software engineer, when Claude 4.0 came out, I had that feeling of like, oh, like, am I going to be needed anymore? Like, this thing is really good. Like, wow. Uh, and so, like, everybody's feeling it in different ways. There was one comment that I wanted to make before, when we were talking about Lindy, that I didn't, that I think now might be a good time for, is that, one of the things that we're doing with the AI Trailblazers, a nonprofit that my wife and I started, the purpose is really to democratize access to all of these different AI tools, and like, if you look at the traditional technology adoption curve, like people that are not college educated or that maybe are not as well off or whatever tend to get access to technology later than people that are more affluent. And so we've got an apprenticeship program that we've created where we basically take people that are, in poverty or in difficult financial situations. We teach them how to build AI-based workflow automations, in this case using Lindy, teach them how to build AI workflow automations, and then help them get higher paying work as a result of that. And we've been able to do that successfully, meaning that like we've been able to take people that have very basic computer skills, capable of surfing the web, capable of sending some emails, that kind of thing, and get them to the point where they're building AI-based workflow automations, solving some of those same challenges that you were talking about like researching contacts and going and doing, sales kind of stuff, right? And so, like, I raised that story because I think that sort of exemplifies where all of us as engineers need to be. Like, we need to be trying new stuff. We need to be learning. We need to be exploring, because these things are changing really, really quickly. We don't know where it's going to take us, but we'll definitely get there better if we do it together.
That's so awesome that you're doing that. Thank you for doing that. That's what a wonderful, worthwhile initiative that is. All right.
Thank you.
Well, Aaron, this has been great. Thank you for sharing some of your knowledge and wisdom with us. How can people get in touch with you?
I'm easy to find. I'm on LinkedIn. My full name, Aaron Eden. The other Aaron Edens in the world are angry because I get Aaron Eden on basically every social network, so you can find me that way on Facebook or on LinkedIn or on Twitter or Instagram or whatever. So pretty easy to find. There's one other Aaron Eden that's in a similar space who lives out in San Francisco.
Oh, wow.
But I'm pretty easy to track down. So please do. Yes. I love this stuff. I love helping others, and love seeing what others are doing with these technologies and how you're changing the world. So like, let me know how I can help or share your success stories as well. I'd love to hear those things.
Amazing. Aaron, thank you so much.
Thanks for having me.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.